Trigonometry, Chapter 1, Trigonometric Functions, Section 3, Trigonometric Functions, Video 2, the Distance Formula. The series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we reviewed the Pythagorean theorem. In any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse, or rather we should say the lengths of the leg and the lengths of the hypotenuse. In this video, we use the Pythagorean theorem to determine how to find the distance between 2 points in the coordinate plane. For example, let's find the distance between the points 3, 1 and 11, 7. To find the distance between these 2 points, we're going to construct a right triangle whose hypotenuse is the segment shown. This is a good problem-solving strategy to solve one problem, embed it inside of a problem that you're more familiar with. If we draw horizontal and vertical lines from the 2 points, we can form the right triangle that you see here. We want to find the length of the hypotenuse. In order to use the Pythagorean theorem, we need the lengths of the legs, how long the blue sides are. So let's think about a visual movement here. We're going to write the coordinates of the points on their corresponding axes. So x coordinates of 3, 11 on the x-axis, y coordinates of 1 and 7 on the y-axis. And now we can see that all we have to do is subtract to find the lengths of these legs. The length of the horizontal leg is the difference in the x coordinates, which would be 11 minus 3. The bottom leg is 8. The length of the vertical leg is the difference in the y coordinates, which is 7 minus 1. The length of the right leg is 6. And now we can set up the Pythagorean theorem. The lengths of the legs are 8 and 6, and the Pythagorean theorem yields 8 squared plus 6 squared equals hypotenuse squared. This is a fairly easy one to solve. Square the numbers to get 64 and 36, add them to get 100, take the square root to get a hypotenuse of 10. So the distance between 3 and 1 and 11, 7 is 10. Well, this is nice, but we want a formula, so we're going to generalize by replacing all specific values with variables and repeat the process. So out with the 3, 1, 11, 7, and in with x's and y's, subscripted with 1 and 2 to distinguish them from each other. It doesn't matter which one is 1 and which one is 2, as long as you're consistent. First x with first y, second x with second y. Draw the right triangle. Write the coordinates on the axes. Subtract the coordinates to determine the lengths of the legs. It is worth mentioning that depending upon how you draw this subtraction problem can come out negative, but we're going to square it, so it's going to be okay. Set up the Pythagorean theorem. The square of the hypotenuse equals the sum of the squares of the legs, each represented by subtraction problems. And then to solve for the hypotenuse, we take the square root of both sides and cancel the square root on the left side only. On the right side, the square root doesn't cancel. You cannot distribute a square root across a plus. The hypotenuse's length represented the desired distance, d, so our distance formula is d equals the square root of the sum of the squares of the differences of the coordinates. Listen to that again. The distance is the square root of the sum of the squares of the differences of the corresponding coordinates. I know it's a long prepositional phrase, but it describes it perfectly. For example, find the distance between the points -1, -7 and 8, -4. Lots of negatives on purpose. First, you should make a clear distinction as to which variables represent which values. You can do this mentally, but writing it down doesn't hurt. Most common mistake people make is using the distance formula wrong by substituting numbers incorrectly. For the points -1, -7, and 8, -4, we have x1 equals -1, y1 equals -7, x2 equals 8, and y2 equals -4. Now substitute in the distance formula, which I had color-coded here for your convenience. Now be careful when you put in negatives. Notice the use of extra parentheses when a negative number was substituted, following a subtraction sign. So back here where we had x minus x1 and the x1 was negative, where we had minus x1 and the x1 was negative, and minus y1 and the y1 was negative, notice I used extra parentheses around them for clarity. This does set up some double negatives that we'll clean up. Complete each subtraction problem first. 8 minus -1 is 9, and -4 minus -7 is 3. Then square, and then add, and then simplify the square root, which, depending upon the number, either comes out nicely, like if it was the square root of 100 to just be 10, but sometimes we get something like 90 that we can break down into 9 times 10, split off the square root of 9, and of course get a 3. This would be the exact answer. If we needed a decimal answer, we could either put this in a calculator or more easily put this in a calculator. This is the distance between the 2 points. Now you try. Pause the video and try the following problems. They're all distance formula questions, so pause it and give it a try. All right, this is your spoiler alert. If you haven't paused the video and tried it, now's your last chance. Solutions in 3, 2, 1.